So today we're going to look at even and odd functions. There are two different ways of determining if a function is even, odd, or if they're not even nor odd, it would be neither. There's several ways of determining if something is even or odd. The first method we're going to do is by graphing, because that's what we see with questions 1 through 6 towards the bottom. So what I'm going to do along the side here, I'm going to box this portion off at the bottom. This is talking about a graph. So graphically, what's going to happen? This little bottom portion here and this bottom portion here. They're both going to tell you what's happening graphically. So if we're determining if a function, for instance, is even, and we're looking at a graph, even functions are symmetric with respect to the y-axis. So that means if you were to fold your graph on that axis, you would be able to see that both sides of that graph line up perfectly. So for instance, for question 1, it says determine graphically the possible symmetry, whether the following functions are even, odd, or neither. So if we are saying that this could potentially be symmetric to the y-axis, I'm going to actually, for me, I'm going to rip this first page off, and I'm going to fold it. What I'm going to fold it over, I want to see if the line pretty much lands right on top of itself. So I have it folded along the y-axis, and one thing I'm noticing, I don't know if y'all can see it from here, but it's like this is part of my graph, and then this part is here. Does it look like it's lined up right on top of itself? No, it doesn't. It looks like if I fold this over along the y-axis, it doesn't look like it folded over right on top of itself. So for this question here, I'm going to make a little note. This one does not look to be even. If it was even, you would definitely be able to see that. Let's try question 2. Okay, again, we're going to fold this along the y-axis, which is vertically. So I'm just going to fold my paper over, and you guys can do the same if there's a back to your page and there's more work. It might be a little difficult to see, but that's why I'm doing it too. Okay, so here's my graph. What do you guys think? Does that look like it lines up right on top of itself? Yeah, it looks like it lines up right on top of itself. So over here for my question 2, I'm going to label that one as even. I want you guys to try to actually fold that paper for questions 3 through 6 and determine, are these even or not? So just either put even or not even for questions 3, 4, 5, and 6. All right, Joseph. For example 3, did this look to be even, yes or no? Yes, it is even. This one, if you fold it along the y-axis, so literally right along this vertical line, you should see both sides of that graph pretty much reflect on top of itself. What about number 4? No, this one unfortunately is not even. Number 5? Not even. And then for number 6? Not even as well. Okay, that's all right. There's another option in case it's not even. Hopefully it will be odd. So before I move on to odd, are there any questions about even as far as folding it along that line of symmetry? Okay, cool. The next one is odd functions. Odd functions are symmetric with respect to the origin. And what you could do with that, and that means you can literally flip the image upside down and it will appear the exact same. I don't mind this issue, don't mind this method, but my issue with it is, for me at least, I can't always tell if it's actually symmetric or if my mind just wants to believe it. So for instance, I know question 1 is not even. So if I was to flip this upside down for odd, it looks like it's going to work out, but for me at least, I can't tell. If you're looking at this and you're like, no, Miss Tapia, that's definitely not going to be odd. Perfect. You don't need the patty paper. If you're like me and you can't tell if it's odd, this is why I use the patty paper. What I'm going to do with the patty paper is I'm going to trace my line. And this should be symmetric with respect to the origin. What you can technically do, and this is what I pretty much do if I'm trying to see if it's symmetric to the origin, I will put my pen, pencil, or whatever I'm using at the origin. And all I'm going to do is rotate this about 180 degrees, so that way I'm literally like flipping it upside down. So in order to flip it or rotate it 180 degrees, I'm going to rotate it here, which is 90. And then I'll rotate it one more time to be 180. Do those look like they line up right on top of each other? Look at the blue line and the black line. Do these line up right on top of each other? No, they actually, it looks like it moves to the left 1 unit. So for this graph, unfortunately, I'm going to make a note. This is not odd. That's why I always use the patty paper, because it looks like it might be odd, but it might not actually be that. So let me look back at the directions. If it's not even or odd, we're just going to make a note that this is neither. And that's all we're doing. Questions 2 and 3, they're already even, so I don't need to worry about that. For question 4, though, let me check to see if this one is odd. So let me take that same piece of patty paper, and I'm going to trace. So I'm going to trace the function that I have. I'm going to center this around the origin, and I'm just going to rotate it. If you want to, you can flip the paper upside down. For me personally, flipping it upside down is the same as rotating it 180 degrees. So I'm going to rotate it 90, and then 180. What do you guys think? It looks like my shading for that graph is a little bit off. But what do you guys think? Does it look like it lands right on top of itself? It actually does. My curving for this clearly is a little shaky, but this one is absolutely odd. So I'm going to make a note here that this should be odd. Do the same thing for numbers 5 and 6. I want you to trace them if you need to and see if these guys are odd. If they are not odd, that means it's neither. It's going to be neither even nor odd. Jude, what do you think about number 5? Does this one look to be odd? It is odd, yes. This one is odd. If you were to take this line and you were going to rotate it around, it should line up right on top of itself. And then what about number 6? Was this one odd? Neither. This one was not odd. So since it's not odd, it has to be neither. Perfect. So that's what's to do graphically. If you notice that the graphs are not symmetric to the y-axis or symmetric with respect to the origin, that's when you determine if it's neither. So those are my different items. Are there any questions about what we have below? All right, let's look at the top portion again. So on this top portion, we talked about graphically. That's when we were looking at the actual graph, seeing if it's symmetric to the y-axis or with respect to the origin. The top ones up here, this is determining algebraically. I hope I spelled that correctly. Algebraically, if your function is even, odd, or neither. The two items at the top. If it's even, odd, or neither. So on the next couple pages, we'll look at it algebraically, and we're going to use a couple of items from the first page. A function is even if this statement is met. F of negative x will equal f of x for all x's in your domain. That means the right side of your equation is even. It does not change the x if it's replaced with a negative x, and we'll talk about what that means on the next page. A function is odd if it meets this statement. So f of negative x is equal to negative f of x. That's what's in here, negative f of x. For all x's in your domain. That means that every term on the right side of your equation changes its sign if x is replaced with a negative x. As of right now, that might not make much sense, but when we flip it over to the next page, it will. So let's go ahead and flip it over to the next page that's talking about verifying. Alright, so to verify algebraically if a function is even, odd, or neither, we must prove the following. For something to be even, I'm just using the directions from the last page. We need to prove this statement. F of negative x will equal f of x. That will be the statement I use to prove if something is even. If something is odd, I need to prove this statement, where f of negative x will equal negative f of x. So f of negative x will equal negative f of x. If neither of the above are true, so if this statement isn't met and this statement isn't met, then we can call our function neither. So it's very similar to what we did before with the graphs. Okay, so let's talk about just basic function notation you should hopefully remember from Algebra 1. F of x is just the original function. So f of x, that's just your original. f of negative x, what do you guys think you're supposed to do? Replace that x with a negative x. You're going to plug in negative x for every x that you see and simplify. So for instance, if I had this example and I wanted to find f of negative x, everywhere that you see an x, I'm going to replace it with a negative x. So in each of these parentheses, I'm going to put a negative x. After I do that, how would I simplify this? What would I need to do? How would I simplify this? What does PEMDAS represent? The parentheses, exponents, multiply, divide, adding, and subtracting. It's your order of operations. So if I was to simplify this, Heaven, in the parentheses, is there anything going on with these x's? Any adding or subtracting going on? You have some number that's being added or subtracted? No. These are just negatives. So no, there's no operation. So I can cross out p. The exponent is negative x. How would you simplify negative x squared? What would it become? What's a negative times a negative? Just x. So we're going to make that a negative x, or excuse me, f of negative x is going to equal x squared. From here, that's the exponent. We're going to do the multiplication and division. So we're going to multiply this. Heaven, what's 3 times negative x? Okay, perfect. And then this plus 5, I'm just going to bring down. Kenya, looking at all of the different numbers and variables here, can I add and subtract all these numbers? No, I can't. So this is going to stay the exact same. So if I was trying to prove if this was even, if I was saying, I want to know, is this function even? Can you look at the original and look at f of negative x? Are these two things the same? No, they're not. What's the big difference between them? The 3x, that's negative here and it's positive here. So because both of those things are different, if it was a question, I would say that this is not even. All right, using that same logic, let's try to do negative f of x. I want you guys to change this a bit because I don't want you to make a mistake later on. I'll use, I guess, my blue pen. I'm going to cross this whole first, really just all of this out. And I want you to label that you are going to distribute negative 1 to f of x. Distribute negative 1 to f of x. You'll thank me later. So let's look at this function, f of x. If I was to find negative f of x, that means I would need to take the negative that's already outside and put it in front of f of x, which is x squared plus 3x plus 5. That's all Algebra 1. That's not pre-cal. That's just all Algebra 1. When you see that negative, guys, like I just wrote, that's the same as having a negative 1. So you're just distributing negative 1 to the entire function of x. When that happens, we're going to make this negative x squared minus 3x minus 5. Heaven, I want you to check. Especially if I was trying to prove if it was odd, I would need to take f of negative x, which is here, and prove that it's the exact same as negative f of x. Look at both of the equations behind it. Are these two the same? No, they're not. Each of these are negative, and this one has only one of them that's negative. So no, it would not be odd. So if that was the case and it wasn't even and it wasn't odd, what would your answer probably be if this was a question? It would be neither. It'd be neither one. So let's actually do that for the questions below. I will make a note before we start. It says to verify algebraically whether the function is even, odd, or neither. The issue is, where do we start? I'm going to put a little star here, and I want you guys to write. I want you to start every single time with proving even. I want you to start every single time by proving that this is even, hopefully. If we can prove that it's even, it'll help you save yourself a headache for later. Why do you think I suggest that y'all start by proving that it's even? Go ahead. You need the even statement to prove that it's odd. This little f of negative x shows up again in the odd statement. So if it's not even, you can immediately take that exact same answer and prove that it's odd, hopefully. That's why we're keeping starting with the even function. So there's always a method to my madness. I'm going to start with example 2 first, and then I'll go up to example 1. You guys can go in whatever order you want, but this is just to make sure we're all on the same page. I first want to prove that this is even. Okay, this is a g of x function, so I'm going to rewrite this as g of negative x should equal g of x. I didn't change anything, I just rewrote it so that way your function represents what you're looking for. Alright, so g of x is already here. That's already given. I need to find g of negative x. So let me rewrite the entire function. And in each of those parentheses, I'm going to plug in a negative x. Valeria, be careful. What's negative x to the 4th power? X to the 4th power, perfect. And is that x in front positive or negative? Say it again. Positive, yes. And then for here, remember, we are following PEMDAS, that's a P. With the exponent, should I do negative 2 times x first or x squared first? Okay, so what's negative x squared? Just x squared. Notice how she just told me it's just x squared? That's why I wrote it the way that I did. We've done the exponent. I just need to multiply this. So g of negative x will equal x to the 4th power minus 2x squared. Valeria, take a look at this. Does the original match g of negative x? Yeah, ignoring that g of negative x part and the g of x, the rest of it's fine, and that's what I want to see. So since I've proven that this statement is true, g of negative x does equal g of x, that means that your function is even. This is an even function. Like I said, there's methods to my madness. Let's look at example 1. If I'm moving too fast, guys, please tell me now. Tanali, you okay? All right, perfect. Let's look at example 2, or excuse me, example 1. So this is prove that it's even. I want to prove, okay, this is an f function. F of negative x will equal f of x. Okay, let's check. F of x is here, the original. Let's check f of negative x. We're going to have negative x, whoops, let me actually rewrite it with my parentheses first. X cubed minus 6 times x. I'm going to put in a negative x in both of these places. Daniela, what's negative x cubed? Be careful. Just negative x? Like that? When we got x to the 4th power, we had x to the 4th when we simplified it. How many x's do you have if you have negative x times negative x times negative x? How many x's do you have? 3. So we're going to make that a cubed. And then, Daniela, go ahead and simplify. What's negative 6 times negative x? Perfect. Daniela, take a look at what we just did. Does this equation match the original? No. So what does that mean? Say it again. I can automatically prove it's odd? Not quite. What does it automatically prove if I show that this does not equal this? What are we trying to prove right now? There we go, that it's not even. If those two statements don't match up, it's not even. Okay, I'm hoping that it's odd, but I have to double check to see if it is odd. So over here, I'm going to write that we need to prove that this is odd. I'm using the same statement from the top of my page right up here. F of negative x is going to equal negative f of x. Hopefully this shows to be true. So f of negative x is already over here to the left. I don't need to touch that. Let's do negative f of x. So that means I'm going to distribute negative 1 to the entire function of x. So negative 1, parentheses, f of x is x cubed minus 6x. Ingrid, what do I do at this point?
So you distribute the negative 1 to everything, so being negative x cubed and then positive 6x.
Okay. Take a second and look at the statement we have. If we're proving that f of negative x equals negative f of x, are these two the same?
Yes.
Yeah. So what does that mean?
That means that it's odd.
It's odd. That would be your answer. There's methods to my madness, guys. There's reasons why I do this. Before we flip this over to the next page, really quick at the top, I don't like for y'all to just memorize things for no reason, but unfortunately, these two rules, I actually do need you guys to try to commit to memory. So the two things that you're trying to prove, that's what you're going to need to pull from your brain and write down on your tests and quizzes. So the for even, prove blah, blah, blah. For odd, prove blah, blah, blah. That's what I need you guys to commit to memory. These two items here. If these two statements aren't met, which we'll see hopefully on the next question, it represents neither. So it's neither even nor odd. With that in mind, let's look at question number 3 on the next page. All right, we're going to look at example 3. If you already know what you're doing, you can easily skip ahead for this. We're going to look at h of x, and first I want to prove if this is even. Hopefully it is, and then we can stop. The function from function statement from the first page says h of negative x is going to equal h of x. H of x is the original. I don't need to worry about redoing that, but I do need to compute h of negative x. So in each of those parentheses, I'm going to substitute in a negative x. Negative x squared is, just x squared, positive. 2 times negative x is going to give me a negative 2x, and then I'll put a plus 1. Sonia, check my work. Does h of negative x and h of x, do those two match? Gross. What does that mean? It's not even. Okay, well, I tried. Hopefully the next thing I find, hopefully this will be odd. So over here to the side, let's prove that this is odd. The statement I need from the last page or the very first page is h of negative x is going to equal negative h of x. Okay, so I already have h of negative x. That was the information to the left. Let's see if negative h of x is true. So we're going to take that negative, and then h of x is x squared plus 2x plus 1. Based on the discussions we've already had, we're going to have to distribute that negative. This is the same thing as a negative 1. So let's see, negative h of x is going to equal negative x squared minus 2x minus 1. Sonia, check these two. Is h of negative x equal to negative h of x? Gross. So this one is not odd. When that happens, Sonia, what's my answer going to be? Yep, it's neither even nor odd. It's going to be neither. On your tests and quizzes, you can just write out neither, and I'll know what you're talking about. I am going to do one last little question with you guys, and then I'll give you 2 to try on your own. Flip it over to question 7, and if you want to get a head start on question 7, feel free. But I'm about to do question 7 with you guys. All right, question 7. You need to prove f of negative x will equal f of x. Remember, f of x is the original function. F of negative x you're going to have to compute. Well, let me put my parentheses before I get lost. X square root of 4 minus x squared. In both of those parentheses, I'll substitute my negative x. Okay, within this, Mohammed, double check this. Can I just change this into a plus sign? Yeah. You can? No. I was like, please don't make me kick you back to Algebra 1. When you use PEMDAS, what are you supposed to do first for underneath that radical? Okay. Is there anything going on in this parentheses? No. No? What about this one out here? No. Okay, so let me rewrite this as f of negative x will equal, I know for sure I can drop that parentheses. Underneath the radical, though, what should I do with that negative x?
Make it positive.
How? Just make it like a big plus sign, or tell me what to write. I have this minus sign. What should I write? What is negative x squared?
X.
Just x?
Yeah.
No. Help them out, guys. X squared. You're supposed to have that squared with it. That parentheses is put around just to remind you you're doing this exponent first, then you're dealing with the negative. Is that okay, Mohammed? The last thing you're going to do is just multiply it, which is really just getting rid of that parentheses. So f of negative x is going to equal negative x square root of 4 minus x squared. Mohammed, take a look at it. Do these two match? Does this match with this? Okay, no. So that means that it's not even. Be very careful here, guys. The simple making this a plus sign, y'all love changing things that y'all don't need to change. Do not change that to a plus sign, please. Okay, I can't prove that this is even. Let's prove that this is odd, hopefully. I'm going to prove that f of negative x will equal negative f of x. This is where I'm worried about your Algebra 1 skills. I know for sure I need to distribute this negative 1 to the x. I know that for sure. Can I distribute this negative 1 to the 4 and the x squared inside? Annie, why not? It's a bunch of inside-outside things. So what were you saying about the square root? Yes. Okay, cool. So yeah, that makes a lot more sense. You're fine. So what Annie was just saying was you can't touch anything under this radical unless there's another radical that looks the exact same. I don't see another radical anywhere in this equation that looks just like this. Radicals, if you think back to Algebra 1, act as variables. You cannot mess with them unless you have another variable or radical that looks the exact same. So for instance, you don't have to write this if you don't want to. If I had negative 2 times, let me actually put a parentheses around that. We'll say x, and then a parentheses with 5. You would only be able to distribute that 5 to the 2 to make it a negative 10. Whoa, that is not a negative 10. To make this a negative 10, and you would have to leave that square root of x alone. As much as you would love to distribute that 5 and show me you know how to multiply, you cannot touch anything under that radical unless it has another radical that looks the same. So, long story short for this problem, guys, do not touch anything under this radical. Leave it alone. So when you write your answer for this, you're going to write it as negative f of x equals negative x, like Annie told me to multiply, and then 4 minus x squared. This would be your answer. Annie, does that mean that this is odd then? Double check these two. Is it odd? Yeah. The negative x is in front. The 4 minus x squared, you cannot touch it. Leave it alone. So this is going to be odd. Give me a nod or shake. Does this make sense with what we just did and why we can't change the numbers inside that radical? It's a cardinal sin. It'll send you immediately to math jail, so please don't do it. All right, I'm going to add in a new question for this. I do want you guys right now to do question 8, but I also want you to do question 11 that I'm going to add over here in purple. Question 11 is f of x will equal x over x squared minus 1. I want you to prove, hopefully, that these are either even or odd. If they're not even or odd, put neither. All right, let's see what you guys got. For question 8, was this even, odd, or neither? Neither. That's a very confident neither. Do I need to go through why this is neither? Don't lie to me. Omar, are you okay? Okay, cool. For number 11, is this one even, odd, or neither? You sure? Let's see. If it's even, for sure you should have taken f of negative x and set it equal to f of x. So if you have f of x, that's the original. F of negative x, you're going to take that x for each of the parentheses that I have, and you're going to replace it with a negative x. So just to confirm, in the numerator, that's negative x. That looks good. X squared minus 1. Okay, this definitely doesn't match with the original, so for sure this is not even. To prove that it was odd, any questions about proving that it was even? All right, for proving if it's odd, you need to prove that f of negative x will equal negative f of x. So that means negative f of x should equal negative x over x squared minus 1. Let me ask you guys this. Can you just switch all the signs there, like distribute it to the numerator and denominator? Jackson, what did you do then? Just distributed to the numerator. This is a number, guys. This is just negative 1. Jackson, if I made negative 1 a fraction, what would be in the denominator? Just a 1. How would you multiply that? Just the numerator by negative 1, denominator multiply that by 1. When that happens, negative f of x is going to equal negative x over x squared minus 1. Be very careful with this, guys. This is odd. Very good job. This is odd. The main issue that I'm worried about, because some students know that they're almost too smart for their own good, and they take that negative and they distribute it to everything. Please don't do that. You're just distributing a negative 1 to prove if something is odd. That's all you're distributing. Does that make sense with what you're doing? Any last questions? Perfect.